Hey there. Today I wanted to make a little video showing how you can create a curvature attribute and field to be used in a flip simulation. This could be useful for a multitude of things like generating a force or an attribute on your points that you could use for meshing or shading, really anything. Yeah, so let's just get right into it. This is my first time doing any kind of tutorial where I'm building a scene or a file as I talk, so I'm probably going to make some mistakes. We'll just see how it goes, but you'll have to bear with me. So what I have here is pretty much just the crown splash shelf tool here. You can see what's happening. It's just a little splash, and I kept it pretty low res here so that we don't have to wait for it to cook for too long. I'm not going to worry about this stuff. I'm just going to be spending most of the time inside the DOP network. Okay, so the first thing that we'll need is a field that we can actually write our curvature values into. And so we do that by creating a gas match field. Now Flip generates quite a few fields for us right off the bat, but there's one in particular that we're going to want to use, which is the surface field, and this is a SDF representation of our fluid. So this is what we're going to want to compute our curvature from. Yeah, so what we're going to do is we are going to reference that surface field, and we're going to write this out to a field called curvature. So we're basically just duplicating that. I'm going to set a few of these parameters just to same as reference, match samples, etc. I don't know how useful this actually is or necessary, but I'm going to do it anyway. The next node we want is gas analysis. This is going to be sort of the workhorse of the setup. There's a variety of different analysis methods you can use here. A good example of this would be inside the flip solver. You might know about, where is this? Under particle motion vorticity. This is a really common attribute. I'm actually surprised that it's not enabled by default because it seems like everybody needs it. So vorticity is generated using a similar setup where you take your velocity field and you generate the curl from that velocity field, and then you analyze again the length of the curl. Or another example would be getting the length of your velocity, which would give you the speed or the magnitude of your velocity. Really useful node. A lot of cases where you can use this to generate interesting fields and forces. Okay, so what we want to do is, using our surface field, we want to analyze the curvature of the surface field and write that out to our curvature field. I'm going to get rid of the stencil field. I don't know if that's necessary because we don't actually have a stencil field. I think it might just default to 0 if there is no stencil field. Either way, I'm going to clear it, and I'm going to set this to always. Next up, gas blur. I want to blur our field just because I think at the resolution that we're working at, it's going to be quite blotchy. So this should help us out just with smoothing things out and making it a bit more usable. But we could always promote this afterwards and adjust the radius as needed. But I will put this back to default for now. And we're just going to put in the curvature field. We don't have to worry about the rest of these. Although if you wanted to mask out your blurring or whatever, you could do that. You can also see the different methods, the filtering methods here. Okay, so we've generated a field. We have analyzed the curvature, and we've blurred it, so now it's usable for us. But how do we use it? So we need to, well, it is usable at its current state, but if we want to put this onto points, we need to grab gas field to particle. This node is also extremely useful, and this will allow us to write out a field as an attribute. This one's super easy. We're just writing out an attribute called curvature using our curvature field, and the particles is going to be under our geometry, which I think we can see in here. Either way. Yeah, there's our geometry. Okay, so that's more or less the setup, and I can show you how this works. Actually, I'm going to do this a bit differently. Another really important thing to consider in DOPS, which is different from SOPs, is that DOPS works left to right. The order is extremely important here. Like, you can't just plug things in randomly. I think it's totally acceptable to plug things in a chain, but I like to, just for the sake of organization, I find it easier to put things in like so. But like an example would be like, we couldn't put the gas blur first because it would be blurring a field that doesn't exist and has no data on it. And same thing, if we put this over here and we reorganized it, we'd be writing out nothing to an attribute. So just a thing to consider when you're working in DOPS. Yeah, so I'm going to plug this in. I have it in the post-solve section, which will be fine, because like, the only thing you'd want to be aware of is if you were to like be placing this inside your flip solver, just not to put it before your surface field's created, but I think you'll be fine. Okay, so we have now a field, and I could just hop outside here, and I'm just going to drop down a color node, and I'm going to say ramp from attribute, curvature. So the first frame will be black because there is no curvature. We're doing it in post-solve, so this will happen afterwards. But here we can see now, I'll let this play through, that we have a field. But you can see the blotchiness that I was talking about just because of the resolution of the sim. And we can see here that we'll get a curvature field. Cool. But at its current state, this might be kind of hard to use. You know, you'll have to be kind of like remapping things all the time. But you know, you can see how you can isolate out, like these are the areas that have the most curvature. Let me change my background here so it's easier to see. Oh, there we go. Yeah, so this can just get a bit tricky to deal with. So I've set up another little way here that we can just simplify this and create us, like, write out our maximum value, so we always know what our max is going to be. There's a few other things you could do. You could normalize the field, so that would basically mean getting the maximum and the minimum values of your curvature and then remapping the curvature to those values, but that's going to cause a lot of flickering. It might be useful, but I found that a better way to do it is using the gas reduce node. This node's really simple. You can just take a field and, you know, using any of these different reduction methods, you can take the maximum, the minimum, whatever. So this is extremely useful. It would be very much like using the maximum function or the minimum function, but I like doing it with this node. And there's another really handy parameter in here called the destination option, which I will get into. So destination is going to be curvature. The source is also going to be the curvature. And then the really useful part here is saying curvature, and then we do a / and we can create a destination in the curvature field here for us to see those values. So if we go back, we can go ahead a couple frames, we can see here that we have a curvature field that's been created, and inside of this curvature field we have this new value called max. If I get rid of this and I go back to the beginning again, we can see that max value is gone. So let's plug this back in, recook, And you can see, yeah, max is right here. So this is really useful. And then there's also a really great parameter that we can use here, which, sorry, I have another file open on the side just so that I can reference things a bit better. And I realize I don't actually have that anymore, so I'll just do it from scratch. That's okay. I'll just drop down a null node, and yeah, we can just set this up. I'm going to leave it as just blank for now. And if we look in here, we can see that it recommends using the dop option function. So let's try that. Dop option. And let's look what it wants. So it wants our dop node, our object, our subdata name, and our field name. So this is relatively simple. What we can do is we can say, or /geo/ or sorry, not /geo. Why is that not popping up? /object /crown/sim. Then it wants our object. In this case, it is called flip tank. Then it wants our curvature field, which also needs to be in quotations. And then our max. Let's hope this worked. I think I got it. Houdini's freezing. Okay, perfect. I did do that correctly. So I can just go through that again. We are taking our dop node, which is object, crown splash. This will usually be inside of another geometry. Like most people don't put their dop networks in the object level, they put it in the SOP level, but that's okay. Then we want the name of our object, which is right here. You can see it's called flip object. Then from the flip object, everything's being written out in this flip tank object, you can see, which would be this. It would be easier to find it here. And you can see that curvature is inside of that. So we're grabbing curvature. And then within curvature, we're grabbing max, which is right here. And you can see that this will write out, so now we don't need this open all the time. And this will write out our maximum value. And you can see that changes throughout time. What I am going to do though is I'm going to just copy this, and I'm going to bring this out to here. And I'm going to drop down another null here. Set these to invisible. Okay, I'm going to float. I'm not going to name it. And I can just paste that here. Now this is a nice function because it doesn't matter like what like it's all very explicit, so it's not going to matter where we place this. So now what we can do is we can use that. Say, well, let's find a frame where we think that we're going to have like quite a lot of curvature. So I can let this cook through. And maybe we'll go at like frame 30, 35 or something like that. Maybe just right here. This looks fine. Yeah, 35. So let's see, what's our max curvature here? We have value of 13. So if we plug 13 into here, I'm also just going to set this to infrared, find it a bit easier. You can see that that more or less gives us like, it remaps us to the maximum value. So this will be like, it's a very easy artist-friendly way to find what your maximum values are. Again, this is, I think, better than normalizing it every frame, because you're going to get lots of flickering, but you know, because at this frame our max is only 6, whereas here it's 13, and so it's going to start by remapping at 6, and it's going to go up, and things will flicker, and it might not be the cleanest for us. Yeah, so this is just about it. Maybe I can show the blurring a bit more as well. Let's set that to 5. Maybe just to see how that affects things. Yeah, we'll let that run through. And 5 might be too high of a value, but yeah, we'll see. And it looks like maybe that is too high, but we can also see now our max is 0.8, so maybe keeping it at 1 is better for us. Yeah, that looks better. It's also interesting how like the curvature starts to it starts to find curvature quite early on. even before the impact's been made, so that might be something to tweak, but yeah, it's pretty cool stuff. I would not go for that high blurring. I'll just keep it at 1. Yeah, so hopefully this was of some use to people. I think DOPS can be a little bit overwhelming when it comes to stuff like this. The resources that side effects provides aren't the greatest. It seems like they're really pushing for soft level stuff, which is nice, but DOPS is extremely useful, extremely powerful, and I think that there's a lot of untapped potential with most people in DOPS. So hopefully this might have inspired you to start exploring DOPS more, or if you were able to find some use of it. That's great. Yeah, so thanks for watching. Have a good one. Bye-bye.